Welcome back. Hopefully by now you've gotten a good start on your project, you know your data, you've calculated some of those group 1 statistics, mean, median, mode, and trimmed mean. So, let's talk about the measures of spread or variation in a data set. So, now that we can actually describe the center, sometimes we want to use the mean, sometimes we want to use the median, depending on the shape of the distribution, whether there are outliers, things like that. We're going to start thinking about the spread or the variation in the data set. And it's important to be able to discuss that for several reasons, one of which being two data sets can have the same measures of center and still be quite different. And we'll see that a little later on in this video. But this is the one section, I think, that we talk about in this semester that really shows that the world doesn't understand statistics very well. So you might hear something like, oh, the unemployment rate in the United States is whatever percent, or the average amount of student loan debt held by Americans that graduated college is this many dollars. And how did they get those numbers? Do we actually know what those values are? I don't think that unless you took a census of all the people in America of working age, we don't know what the true unemployment rate in this country is. So when that number is reported, that is not the true value. It might be a very good estimate based on a sample, but there's uncertainty there. The true percentage is probably not that. So, that estimate is that measure of center. That's a proportion, not a mean or a median, but you understand, right? But it's important to be able to say, we estimate that the unemployment rate in this country is this percent, but we're uncertain about that, so we're going to put a margin of error on that estimate. So maybe the unemployment rate is 10% plus or minus 2%. Right? So in the survey that we took, 10% is our best guess, but it could be anywhere from 8 to 12 reasonably. That paints a more accurate picture of what you want to know about the population. So that's why we're going to be talking about the measures of spread or variation. Let's see here. And that's really what this class is all about. This is not a math class, because in math, you have a problem, you do the steps that you need to do, and you get an answer. Statistics is all about how to deal with uncertainty in data, right? You're never going to have a census. You're never going to be able to get every individual in the population. So we have to be able to say something about the population, even though we don't know everything. And that's where the ideas in this section really come in handy, because it attaches a number to the uncertainty involved. And a lot of people out in the world do not understand how to do that. So if you understand what we go through in this section, you're going to be miles ahead of so many other people who misuse statistics and data because they don't understand. And I think that's cool. It's one of the reasons I'm teaching this course, so more people are educated in this regard. This section is very important, and it's easy to lose sight of what the idea is here for all the details in the calculations that we're going to talk about. Okay, but we're essentially talking about what we don't know. We're quantifying the unknown. I guess that's a cool way of saying it. Anyway, let's talk about variation. We can say what the mean or the median of a data set is, but it's important to talk about how spread out it is, because it's not enough to think about center. That doesn't describe every GPA or shoe size or annual income in a population or sample, because you're probably not going to get data from every individual. So the measure of center is fine, but there is uncertainty there. We want to be able to describe it when we take a sample. So let's talk about how we can do that. Just like when we talked about measures of center, there are multiple different ways to describe the amount of spread or variation in a data set. We're going to focus on 3 of them in this section. There were 4, but one of them is a little more obscure, and I decided, especially in this virtual environment, it wasn't particularly necessary. So if you look through the textbook, it describes Chebyshev intervals. We're throwing that out for this semester. You don't need to know anything about that. We're going to focus on the other ones. So let me actually erase this and start with a fresh board. I think I'm going to need all the space I can get. All right. So I've tried my best to recreate what's in the notes on my wall here. I usually have the actual note sheet projected on the board in my classroom, so it's a lot easier to like make this table that we're going to be using, but I tried. I hope it's legible and whatnot. If not, I apologize. So we are going to calculate what are called standard deviations for each of 2 data sets. These are the 2 data sets. You've got data set 1, which is 5 6s, 5 7s, and 5 8s. So 15 values in all, 5 each of 6, 7, and 8. Data set 2 is all of the whole numbers between 0 and 14, inclusive. Okay. What you might notice about those 2 data sets is they have the exact same mean, and do they have the same median? The median of this one is 7 for sure. This one, there are 14 values, so it would be between the 7th and 8th values, which is 6 and 7, it'd be 6.5. In any case, the measures of center for these 2 data sets are either exactly the same or very close. So, would we say those data sets are the same or very close? Of course not. They're very different. Look at all those numbers. They're so different. So this is a good reason to talk about measures of spread or variation. How spread apart are the numbers in these data sets? You may be able to see that if we were to calculate, if we were to quantify, to boil down how spread out are these numbers into a value, a statistic, that statistic for data set 2 should be bigger than for data set 1 because the values here are more spread out. So one of those measures of spread or variation is called the standard deviation. And that is what we're going to calculate for each of these 2 data sets. Actually, we're going to do it for data set 1 here. Only data set 1 in this video. Data set 2 is going to be your job. But we will talk about the steps to calculate the standard deviation. We're going to use this table to calculate the standard deviation by hand. Now, if you end up taking more stats courses in the future, whether it's AP Statistics at Anderson High School or a stats course in college, you may well be asked to calculate these standard deviations using technology, like a calculator. And there are 2 reasons why we're not going to do it that way here. 1, not everyone has one. Okay, if you don't have a fancy graphing calculator, you're missing out on that. I suppose you could use the virtual calculator. Anyway, the second reason why is, now that you're just first being introduced to what a standard deviation is, it's important to see the steps involved in how it's calculated. If you go straight to using a computer or a calculator, you won't understand the nuts and bolts of how this works, and that will weaken your understanding of what it does. Okay, I don't want you going through your life being like, standard deviation, I know what the number is, but I don't know how to interpret it. That part is important too. And that's where being able to calculate it by hand, seeing where it comes from, is important. I think it's worth it. So, it is a 7-step process, as you can see in your notes. And the first step, using this table, which is on the back of the note sheet, it has 3 columns. Okay. The first column we are going to label with an X. Okay. So this table has 3 columns. It has 16 rows. The reason it has 16 rows, the first row is going to be for labeling each column. And again, the first column is labeled X. The other 15 rows are going to be for the 15 numbers in our data set. If we only had 8 values in a data set, we would only need 9 rows in this table. Okay. So, first step, step 1, label the first column X. And then we're going to write all the data values in that column. So we're going to take all the values of data set 1 and we're going to list them in the first column. So we can go ahead and do that. That would be boring for you to watch, so I'm just going to edit to the point where they're all there. Hey! All right, there we go. So that actually didn't take very long. I didn't have to cut that out. Maybe I didn't, who knows? So step 2, once we've got that first column filled out, we're saying that the standard deviation, what the process that we're going through calculating here, is a measure of how spread out the data values are. Spread out from what? Well, it turns out that the measure of center we're going to use, if we're calculating standard deviation, we're going to use the mean as our measure of center. So step 2, we want to see how far spread out these data values are from the mean of the data set. So we need to calculate the mean. And we're going to treat these data sets as samples, not populations. So if I wanted to note the sample mean of this data set, that would be written as X bar. Okay, so we need to calculate the sample mean of our data set there. And usually, in your notes there is space underneath this table. I kind of ran out of room here, but I usually write whatever the sample mean turns out to be under column 1. So, to calculate the sample mean of data set 1, add all those values together and divide by the number of values there are, 15. You may be able to guess what the mean of that data set is. It's 7. Okay, I won't go through how it's calculated, but if you got a whole bunch of 6s, a whole bunch of 7s, and a whole bunch of 8s, and they're the same amount of each number, that means going to be 7. So I'm going to put X bar equals 7 right down here, just so we remember that. Okay. Even better would be if you wrote out like X bar equals 6 plus 6 plus dot 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 plus 8 divided by 15 equals 7, to show how it works. That would be best. But that is step 2. Step 3. Now that we know the mean, we can actually fill out the second column of our table. We said that the standard deviation was going to be how spread out the data values are relative to the mean. So we're actually going to take each of these data values and subtract the mean from them, so we know how far away from the mean they are. So step 3 is to label the second column X minus X bar. Okay, the first column is X, those are just the data values. The second column is X minus X bar. Okay. So what is it we're going to fill in with the second column? Well, we're going to take the data value, X, and subtract the mean, 7. So we're going to take the difference of data value and the mean in each row. So as you get more used to making this table and calculating the standard deviation, I promise you won't have to do it too many times, but it will be a few. For this first example, I'm going to write out the calculation in the table. Once you get more familiar with how it works, you won't need to do that. But I'll show that in this first row, x is 6 minus the mean is 7. That's going to give you -1, right? So if you're comfortable, all you would have to put in this cell is -1, right? And that's going to be the same for all the 6's. If x is 7, and you subtract the mean of 7, that'll give you 0, and that'll be the same for all the 7's. And then if x is 8, and we subtract the mean of 7, that's going to give us +1 for all of these. Okay. So that column just has a bunch of -1s, 0s, and 1s. All right. So I want you to do me a favor real quick, and I want you to add up all of the values that you have in that second column. Add them up. What do you get? Zero, right? Is that the measure of variation? No. Okay, we're not done, obviously. There's a third column we haven't quite filled out yet. In fact, as long as you calculated the mean correctly, it's actually a good place to check your work. If you add up all the values in the second column, the x minus x bar column, they should equal 0. Because if you take all of the differences, on average, they should be the mean. Or they should be the mean, which means the difference should be 0. Okay? So that second column should always add up to 0 no matter what. But since there is variability in this data set, that means we've still got something to do, right? We're not just going to stop there. We've got more. And it turns out there are 4 more steps involved. We are ready to fill out the third column of the table, though, in step 4. We will label the third column let's not get too far ahead of ourselves here. Does it matter that the 6's are 1 below the mean and the 8's are 1 above the mean? If we're just trying to measure how far apart the values are. Positive and negative differences don't matter. Okay? So I don't really want to have negative numbers as part of the calculation. We want those negatives to go away. I also want, at the same time, to get rid of the negatives, and the further away a value is from the mean, so if you imagine that there was a value here where this number was really big, like 10 or 15 or something, I want that to count a lot more. Okay? I want this measure of variation to explode if there are any values really far from the mean. I want them to have an outsized influence. So what kind of operation could we perform on these numbers to get rid of negatives and to really embiggen the effect of large numbers? If you're saying absolute values, that will get rid of the negatives, but the absolute value of -1 is just 1. The absolute value of -5 is just 5. I'm thinking squaring, right? Squaring a number gets rid of the negative, if it is negative, and the bigger a number is, the square has a bigger effect. -1 squared is just 1, but -4 squared is 16. -10 squared is 100. Okay? So, we're actually, in this third column, going to take these values and square them. So the third column is going to be labeled, you might actually know, it's the second column squared. Right? It's just x minus x bar squared. and we're just going to square each value from column 2. It's actually quite simple. You'll find that a lot of the mathematics in this class are not difficult. Okay, it's just a matter of knowing how to apply them. Okay, so this column is going to be labeled x minus x bar squared. And we're just going to square these values. So again, for this example, I'm going to write that calculation out. We're taking -1 squared, and that equals 1. As you get more familiar with going through this table, you would just have to write the number 1 here. Zero squared, 0 times 0 is 0. And obviously 1 squared is 1. Okay. So for this particular data set, these values are not super interesting. You, later, once we're done, will do this entire process for data set 2. Those numbers will become a little more interesting. So that's step 4. Our table is filled out, but we still have 3 steps left. So, what are we going to do with these values? Well, the only numbers we are going to be interested in at this point are the ones we just calculated here in the third column. Okay? These are the squared differences between each of the original values and the mean. Okay? We want to combine all those into a number. And the easiest way to do that is to just add them up. So we're going to add up all values in column 3. So as we go through each step from here, I'm going to write the formula for what we have. Up to this point, we've been doing that with our column labels. Okay? If we add up all of these values, we're essentially taking the sum. Okay? So this is going to be the sum of the x minus x bar squareds. Okay. So let's calculate that. We add up all the values in column 3. And again, if I had more room, I would be writing this calculation under column 3. Since I don't have that room, I'm going to go write it off to the side. You could write it here as well. Sum of column 3. Okay. We add up all these numbers. That's just 10, right? 5 ones, 5 zeros, 5 ones, that's 10. Okay. Now, this is not the number we're looking for, unfortunately. Okay. We actually need to take into account how many data values there are. Because this sum being 10 means something different if there are 15 values versus if there are 100 values or 3 values. Okay. So we want to take into account the sample size. So step 6, we're going to take this sum and we're going to divide it. And we're going to divide it by n minus 1. Remember, n is the sample size. We're going to divide this number by n minus 1. Why is it n minus 1 instead of n? I actually don't want to talk about that right now. I actually won't even talk about it in AP statistics if you take that class. It's actually kind of complicated why it's n minus 1. It's just part of the formula. You will need to know this, okay? But we're just going to take this sum and divide by n minus 1. Okay. So in formal mathematical notation, it looks like this. really fancy, right? We're just taking 10 and dividing it by whatever n minus 1 is. So we need to take 10 divided by, we said there were 15 values here. So we're dividing by 15 minus 1. This is 10 over 14. It's 5 over 7. Let's go ahead and make that a decimal. That's 0.714. Now, this is still not the standard deviation of this data set, although we are very, very close. And it's about time we got there, right? But this value does have a name, and it is important, and you will need to calculate it for your project. This is the variance. This is the variance. V-A-R-I-A-N-C-E. The variance of the data set. So this is the variance. Okay. So what we're interested in is the standard deviation, whatever that is. This is the variance. What does this number tell us? It's got a name, so it must be something important, right? Well, yes. The main problem with this number is it's in the wrong units. So I didn't give you any context for these numbers. They are what they're just numbers to you. But if we said that these were like dollars, how much something cost in dollars, okay, then this number, its units would actually be squared dollars. Who's ever heard of that, right? There's no interpretation of squared dollars. Why are they squared? Because we squared those differences. And we haven't done anything to undo that yet. So the variance is important, but since the units are still wonky, in order to get it into the right units, we need to undo this squaring. So what's the opposite or inverse operation of squaring something? Taking the square root. That's your seventh and final step. Step 7. Take the square root of the answer. Okay. So in terms of the notation, ooh, that's an ugly looking sigma. We're just taking everything we just had for the variance, and we're just taking the square root of the whole thing. Okay, so this is the mathematical formula for what we're looking for. Let's actually calculate it. We need to take the square root of this number, 0.714. I'll give this the approximation symbol instead of an equal sign because we've rounded already and we're about to round again. If you take that square root, you get approximately 0.845. 0.845. This is the standard deviation. The standard deviation. Okay. So there's your process for how to calculate the standard deviation. There are 7 steps. Yes, there's a big table involved, But none of the calculations we performed are really all that difficult. As long as you can copy down these numbers, find the mean, which we talked about in section 1, subtract, square, add, divide, and take a square root, you know how to do everything you need to know. I don't think that's particularly asking a whole lot. Okay. What does this number mean? How do we interpret it? Well, it's kind of in the name. It's the standard deviation. It's kind of like the average distance each of these numbers is from the mean. You might be looking at me like, Mr. C, I'm sorry to tell you, but like all these numbers are either the mean or one away from the mean, not 0.845. You're right, but this number is taking into account that the true, I don't want to say average distance because it's not that, but the 0.845 reflects the fact that there are a lot more ones and negative ones than zeros here. So this number is closer to 1 than 0, but it's also pretty close to 1. So you can think of it interpretation-wise as like an average distance any random data value is from the mean. Okay. There will be other interpretations of the standard deviation that we'll get to later in the course. It will make a lot more sense once we know those other applications of it. But now that we're just learning what it is, that's the best interpretation I can give you. It's kind of a typical distance a random data value is from its mean. Okay. So what I would like you to do, first of all, if you got through this video, golf clap. It was a long one and it wasn't particularly exciting. I apologize. I want you to go through this process for data set 2. All right. First thing in the next video for tomorrow, I think it's tomorrow, for the e-learning day, I will give you the table and the calculations for this data set so that if you did it, you can make sure that you did it correctly. If you did, you're good to go for any data set I give you. You should be able to calculate the variance and the standard deviation. And those are 2 things you're going to have to do for your project. So you have 2 data sets, kind of like these. You will need to create this table and calculate these statistics. That's going to take so long, Mr. Z. No, it's not. Not really, right? Yes, you've gotten more numbers in your data set, but again, these calculations are not difficult. I will need to see the work for your project as well. Okay, so don't just use some kind of function on your calculator or on Google Sheets or something to get the answer right away. I want to see the work. If you don't show me the work, your project will be worse. You will get fewer points. I want to see this table because I want to know that you understand how the standard deviation is calculated. It is a solid foundation from which we will build later in the class. So, there are actually a couple days built in for things. There is one more video you'll get for tomorrow about this section to finish it up. The next couple days, you'll have to work on the homework for this section in the textbook and to do this calculation for your project. Okay, 2 of the 3 things you need from this section are the variance and the standard deviation. By going through this process, you will get both of them. There is one other measure of spread you'll need to calculate. We'll talk about that tomorrow. And I think that's all I have for this one. So, make sure, go through this process with data set 2. Make sure you've got it down cold. That way, by the time that a homework assignment, or maybe a quiz, or a test comes around, you'll know how to do it. That's what I want to see. So, we will see you in the next video. Have a great day.